We always talk about the cloud like it's some kind of magic, right? This invisible, weightless place where all our photos and files just live. But the truth is, the cloud isn't a cloud at all. It's real, it's physical, it has addresses, thousands of them. So today, we're going to pull back the curtain and take a journey to find the physical cloud, this massive, hidden infrastructure that powers our entire digital world. Okay, so just to wrap your head around the scale we're talking about, get this. Every single minute, more than 400 hours of video are uploaded to YouTube. I mean, think about that. That's every single minute. The amount of data we're all creating is just unbelievable. So that just begs the question, doesn't it? When you upload that video, when you save that photo to the cloud, where is it actually going? It's definitely not floating around in the sky. So where does it all physically live? Well, the answer is pretty mind-blowing. It's not in one place, it's in a massive planet-spanning network. The cloud is really a global web of gigantic, super secure buildings, all linked together by hundreds of thousands of miles of fiber optic cable. Let's take Microsoft's Azure network as an example. They've got over 60 of what they call regions all over the world. That's more than any other cloud provider. And they're all connected by more than 160,000 miles of their own private fiber optic cable. And here's the really cool part. Because they own the network, when your data moves from one data center to another, it never even touches the public internet. It stays on its own private, secure, super fast highway. And this whole network isn't just a bunch of buildings thrown together randomly. No, it's a brilliantly organized system designed for resilience. At the highest level, you have a geography, which is usually a country, to handle all the local data laws. Inside that, you have regions. These are sets of data centers that are hundreds of miles apart. So if a disaster hits one, the other is safe. And then inside a region, you have multiple availability zones, each with its own independent power and cooling. It's all about building in resilience at every single level. Okay, so we've seen the big picture, the view from space, basically. Now let's zoom in, like way in. We're going to go inside one of these digital fortresses. And to get in, you have to get through an incredible 6 layers of physical security.
So let's do it. We're going to peel back each of the 6 layers that stand between the outside world and the servers holding all our data.
All right, this is like a real-life Mission Impossible. Layer 1 is just the property line with basic signs and fences. But Layer 2, that's when things get serious. We're talking anti-climb fences, 24/7 guard patrols, and even vehicle crash barriers that can stop a truck in its tracks. To get through Layer 3, the building itself, you need multi-factor authentication, including iris scanners that literally scan your eyeballs to prove you are who you say you are. Layer 4 is the Security Operations Center, a command hub watching every single camera and alarm 24/7. Then you get to Layer 5, the data center floor itself, a place so restricted that only a tiny number of techs can ever get in. And finally, there's Layer 6, asset destruction, where old hard drives go to be completely, utterly destroyed. And believe me, when they say destroy, they are not kidding around. After wiping the data multiple times, the physical drive goes into a crusher that just obliterates it. There is zero chance of recovery. That disk is history. Okay, deep breath. We made it. We're past the fences, the guards, the iris scanners, the whole shebang. We are finally standing in the heart of the machine, the data floor itself. And just to give you an idea of how rare this is, less than 1% of Google's own employees ever get to set foot in here. This is easily one of the most restricted places on the planet. And calling this a room is, well, it's a massive understatement. A single hyperscale campus can have over 20 buildings on 300 acres of land. Inside, you might find almost 500,000 individual computers, holding the data equivalent of more than 50,000 libraries of Congress. I mean, just try to picture that. And of course, every bit of that data is encrypted while it's sitting there. Right, so keeping 500,000 computers humming along 24/7 in one spot, that takes an absolutely insane amount of power. So how on earth do they manage it, and how are they trying to make it more efficient? The way they measure this is with a metric called PUE, which stands for Power Usage Effectiveness. It's actually a pretty simple idea. You just take the total power going into the building and divide it by the power the computers are actually using. A perfect score is 1.0. That would mean every single drop of electricity goes directly to computing, with nothing wasted on stuff like cooling or lights. And what's really cool is you can see how they've gotten better and better at this over the years.
Their first-gen data centers had a PUE of over 2.0, which, by the way, is still pretty common for a lot of companies. But with each generation, they've innovated. In Gen 4, they started just using the outside air for cooling, which was a huge leap. Now in Gen 7, they're using smart software to manage everything, driving that PUE all the way down to as low as 1.15. That is a massive gain in efficiency. But this whole push for efficiency isn't just about saving money. It's part of a much, much bigger commitment. Microsoft has actually been carbon neutral since way back in 2012, but their goals now are just huge. By 2025, they want to be powered by 100% renewable energy. By 2030, they're aiming to be carbon negative, meaning they take more carbon out of the air than they put in. And this is the kicker. By 2050, their goal is to remove every bit of carbon the company has ever emitted, all the way back to 1975. Okay, so we've seen where we've been and where we are now, but where are we going? Well, the future of the cloud might just be underwater. This is Microsoft's Project Natick, and it's a pretty wild idea. They're testing what happens when you sink entire, sealed, self-contained data centers and just leave them on the ocean floor. It sounds like something out of a science fiction movie, but it actually has some incredible benefits. The advantages are huge. I mean, the most obvious one is cooling, right? The deep ocean is naturally ice cold, which gets rid of one of the biggest energy costs. They can also be built and deployed in just 30 days instead of the years it takes to build on land. But the most mind-blowing discovery they made was about reliability. I mean, look at this. The difference in reliability is it's off the charts. On land, you expect about a 6% server failure rate, but inside that sealed underwater capsule, which they filled with nitrogen instead of regular corrosive oxygen, the failure rate dropped to less than 1%. That's 8 times more reliable, all because they took oxygen and humidity out of the equation. Just incredible. So, from a planet-spanning fiber network to iris scanners and even data centers at the bottom of the sea, it's pretty clear we've built this colossal, hidden physical world just to power our digital lives. It really makes you wonder, right? As our digital world just keeps getting bigger and bigger, what's the next incredible thing we're going to have to build in the real world to support it?